Continuing on with the last two area problems. Number 7, a square is altered so that one dimension is increased by 5 inches and the other dimension is decreased by 2 inches. If the area of the resulting rectangle is 98 square inches, find the area of the original square. So that's a lot of information to digest there. Let's draw some pictures. So I have a square. And what we know to be true about a square is that all sides are the same. So that means in this square, the lengths of all sides we'll call x. So it is altered. So basically the square is going to become a rectangle now. One dimension is increased by 5 inches. So if it was x to begin with, it is now x plus 5. The other dimension is decreased by 2 inches. Obviously, mine is not drawn to scale, so decreased by 2 would be x minus 2. If the area of the resulting rectangle is 98 square inches, find the area of the original square. Well, in order to find the area of the original square, I need to know the value of x. So to find the value of x, I'm going to use my rectangle drawing and solve just like we did on the first page. So length times width, x plus 5 times x minus 2 is equal to 98. Okay, hit pause to solve for x. Hopefully you found that the value of x is 9. Now, that doesn't answer the question. Let's go back to the question. Find the area of the original square. So if the value of x is 9, that means in my original square, the length of each side is 9. To find the area of it, I'm going to take 9 times 9, or 9 squared, and I get 81, and my label inches squared. Number 8, given the diagram to the left, if the area of the shaded region is 59 square inches, what are the dimensions of the outside rectangle? We did some problems like this earlier in the year. To find the area of the white, to find the area of the shaded, okay, so to find the area of the shaded, I'll call that A sub S, we take the area of the outside minus the area of the inside. So to find the area of the outside, I need to multiply 2x minus 1 times x plus 6. And then I'm going to subtract the area of the inside. X times x plus 3. Okay, let's simplify that. I need to FOIL my binomials on the left. So firsts gives me 2x squared. Outers gives me 12x. Inners gives me minus 1x. Lasts gives me minus 6. I simplify that and it gives me 2x squared plus 11x minus 6. Okay, on the right hand side, if I don't have to FOIL here because it's a monomial times a binomial. So I have x squared plus 3x, and what I'm doing is I'm subtracting that entire thing. So what that means is I need to distribute the subtraction sign through. So that gives me minus x squared minus 3x. And the area is 59, so we set it equal to 59. Okay, let's simplify the left-hand side of my equation. I've got 2x squared minus x squared, well, 2x squared minus 1x squared is just x squared. And then what else do we have for like terms? 11x subtract 3x gives me 8x. And then I've got my minus 6 equals 59. Always, always, always set it equal to 0. So bring your 59 over. X squared plus 8x minus 65 equals 0. Let's factor. As you hopefully noticed, these problems are repetitive. So once we got our trinomial, we set it equal to 0, and then we factor our trinomial. So what multiplies to negative 65 and adds to positive 8? Positive 13 and negative 5. So positive 13 and negative 5. So what plus 13 equals 0? Well, that's negative 13. And what subtract 5 equals 0? That's 5. I can't have a negative. Let's look at what the question is asking us. What are the dimensions of the outside rectangle? So if the x is 5, I got to find what those would be. 2 times 5 is 10. Subtract 1 is 9. So 9, what are my units? Inches. And then my other dimension, 5 plus 6, is 11 inches.